Trichy. The aim of the experiment is to verify the Bronsted-Jerome equation and to determine the strength of given potassium nitrate solution. Principle: in a system of multiple reactions, the reaction between same charged ions is slower compared to ion molecule or molecule reactions. It is due to the collision between same charged ions is repulsive in nature. So reaction 1 is much slower compared to reaction 2 and 3. Reaction 3 can occur only if molecular iodine exists in the chemical system. Since the produced molecular iodine in reaction 1 is consumed by thio in reaction 2, reaction 3 cannot start due to the unavailability of iodine. Reaction 3 can be started only after the completion of reaction 2, and reaction 2 will stop after the concentration of thio is completed. It means after the completion of thio there will be an appearance of blue color. Here the rate of reaction can be given by rate equal to 1 by 2 into concentration of thio divided by T, where T is the time taken for the appearance of blue color. According to Bronsted-Jerome equation, the rate of reaction is directly proportional to the ionic strength of the reaction. Indicates that higher the ionic strength, faster the rate of the reaction. Apparatus and chemicals required to carry out the experiment: 0.01 molar thio, 0.05 molar potassium iodide, 0.05 molar potassium peroxydisulfate, 0.4 molar potassium nitrate starch solution, and distilled water are the chemicals required for this experiment. 12 conical flasks, 4 400 ml beakers and 3 measuring jars are the apparatus required. As showed in the table 1, in all the experiments the volume of peroxydisulfate, thio, potassium iodide and starch are fixed. The volume of potassium nitrate systematically increased, and to make the total volume 100 ml, water is added as required. In this experiment, 100 ml measuring jar can be used to take water and potassium nitrate. 20 ml measuring jar can be used to take 12 ml mixture of potassium iodide and starch. 10 ml measuring jar can be used to take peroxydisulfate and also thio. Take peroxydisulfate, thio, potassium nitrate and water in a conical flask as showed in the experiment 1, and take the mixture of potassium iodide and starch in a 20 ml measuring jar and then add them. After adding potassium iodide and starch in a conical flask, start the stopwatch. For us, it took 340 seconds to get a blue color in experiment 1. We know that the amount of potassium nitrate in experiment 1 is lower, indicating the lower ionic strength. Now look at the complete video of experiment 10 where the ionic strength is higher. experiment 10, the appearance of blue color was faster. It took only 56 seconds. Similarly, all other experiments have to be performed and the corresponding time of appearance of blue color has to be noted in table 2. The molarity of potassium nitrate in 100 ml solution can be calculated by the formula showed here. The ionic strength can also be calculated using the formula mu equal to 1 by 2 sigma Ci into Zi square. Ci is the molarity of potassium nitrate, Zi is the charge of ion. The concentration of potassium nitrate in experiment 1 is 0.02 molar. So, the ionic strength also found to be 0.02 as calculated here. The plus 1 and minus 1 are the charges on potassium and nitrate ions. After calculating all the values in table 2, the graph between log of rate versus square root of ionic strength, that is square root of mu, can be plotted. Using the graph, the unknown concentration of potassium nitrate can be calculated as demonstrated here. Finally, in result, you have to confirm the verification of Bronsted-Jerome equation and report the unknown of potassium.